Good morning, everyone. I think we're morning everywhere for a change. So good morning and welcome. We'll just give about 30 seconds for the rest of the attendees to come in to the webinar today. All right, we will get started since we've got a lot to cover today. We've got a really packed webinar for you today. Thank you for joining us. My name is Mark Rosen. I'm the Director of Building Science at Building Knowledge Canada. And we are bringing you today a webinar in our Critical Canadian Building Science webinar series, all about the NBC 2025, which was published on December 22nd. I've had a few people comment that they canceled all their Christmas plans to read it over the Christmas break because they were so excited, but we do have the published document in hand. In today's webinar, we're going to touch on some of the biggest changes that are a part of that NBC 2025, specifically as it relates in and around the residential and energy sectors of that building code. We'll have a couple of great guests today. Frank Lohmann and Mike Memme are with us. I'll give them a proper introduction in just a moment, but great to have you both here. Here's a little look at what our agenda is going to cover today. So first and foremost, we're going to also say welcome to Mark Rosen, who's going to give us a little introduction from Enbridge and a welcome and land acknowledgement. We'll go over the housekeeping rules for the webinar, and then we're going to get into the meat of the discussion between the three of us. Today's webinar is going to be very conversational. We're going to offer, my perspective as an energy advisor, and then Frank is going to bring us the perspective of the National Association representing builders, and Mike is going to give us the perspective of a builder working on the ground building homes in Ontario. And hopefully those three levels of perspective will generate some interesting discussion points for us to mull on. We will leave some time for Q&A at the end, and we'll go over the housekeeping of how to ask your questions in just a moment. But first and foremost, Mark, I'd like to hand it over to you to a word from our sponsor and a welcome.
Great. Thank you very much for the warm welcome. As Mark mentioned, my name is Mark Rosen, and I'm the manager of mass market strategic accounts at Enbridge Gas, where we work closely with our strategic builders, developers, HVACs, industry associations, both in Canada and the US. Today, we'd like to start the session by acknowledging the land on which we gather as the traditional and historical land of the original people of Turtle Island, who have been the caretakers of these lands since time immemorial. Today's gathering is the place and home of many First Nation, Métis, and Inuit people. Our acknowledgement of this reminds us that of the great standard of living that we have is directly related to the resources and relationship with the Indigenous people. And we have responsibility to honor that. So thank you. And to the next slide. Something at Enbridge that we like to do as well is start each of our meetings with a overall safety message. And recently here, so I'm calling in from Chatham, Ontario, so southern part of Ontario. And we had quite the rainstorm last night, as well as another storm this past weekend. So thought that great message could be power outage protection. So prioritize your safety. So just a few different tips about planning for the storms as they tend to come in the spring timeframe. So keep those refrigerators closed when there is a power outage. Why this matters, it preserves the food and reduces energy loss. So an unopened refrigerator can keep your food cold for up to 4 hours, and a full freezer up to 48 hours. So just try to minimize the doors opening and closing. Disconnect any sensitive appliances and electronics. This prevents damage from power surges when electricity is restored. So unplug those TVs, those computers, small appliances, and then you can reconnect everything gradually. If you are using a generator, ensure that you're only using it outdoors and keep it away from windows. And why this is important is because it prevents carbon monoxide poisoning. So never use generators indoors, in garages, or near windows and doors. Carbon monoxide is invisible and it can be very deadly. In terms of medicines, plan ahead. And if you have anything that needs to be kept refrigerated, again, keep it in the fridge and closed. Why this matters is health and safety of being able to take your medication on a regular basis is very important for continuity. So speak with your healthcare provider in advance of any planned outages, or if you know some storms are coming your way, just to ensure that you have everything available that you need. Do not use gas stoves or ovens to heat your home. These units have a particular purpose. So they're designed specifically for cooking and not necessarily heating wide open spaces. So not using them properly could result in serious safety risks and could cause more carbon monoxide exposure. And also it could impact overall reliability over time. If safe, if it's safe to do so, you can leave your home and find a place to stay warm for extended periods of time. So this prevents cold-related illnesses. Some natural gas heating systems do allow for you to remain within your home. So ensure that you understand what those ones are, and if you're able to start them up manually. It's important that if you're choosing to do so, that you follow all the manufacturer's protocols in doing that. And then finally, check on your neighbors, especially anybody that's vulnerable or within your neighborhood that could use the help. Just knock on the doors, ensure everyone has food, safety, and support as required. So that's the safety message piece. And then one quick, brief little overview for those who don't know who we are. We are Enbridge Gas. So next slide, please. And we support over 4 million customers across Ontario within 317 different municipalities. And there's about 65,000 new attachments over the course of 2025 and 2026 that we were able to connect within the province. We also provide natural gas service in Quebec, Ohio, Utah, Wyoming, Idaho, and North Carolina. So 7.1 million customers across North America. We deliver large-scale energy that keeps pace with the population growth across North America. And it is an affordable energy option. It provides the essential winter heat that millions of Ontarians depend on. And during periods of peak demand, our gas system carries more than 5 times the energy load of the electric grid. So this ensures people can stay within their homes and while systems remain stable. So during heat waves, cold snaps, ice storms, some of which we experienced this past winter, the natural gas consistently flows and ensures that we're able to meet demands as the overall system faces some stresses. So this protects our homes and it strengthens overall resiliency. With that, I just want to thank you again as the sponsor, and we look forward to another great session. And back to you, Mark, Frank, and Mike.
Thank you so much, Mark. And thank you again for Enbridge's support of this webinar series. It's great to have you here to offer that land acknowledgement for us this morning. So appreciate that very much. So who are we presenting to you today? As I mentioned, my name is Mark Rosen. I've been working as an energy advisor for about 18 years at this point, which sort of surprises me when I say it out loud, but it has been a fantastic journey. I've been with Building Knowledge now for 3 years in the role of Director of Building Science, and I am a recovering architect in my past life and still hold that designation. So my role in today's webinar, as someone who's been a part of the code development process as a member of committees and task groups, is to peel back the curtain a little bit on what these changes mean and give you a brief overview of them before we get into a discussion about what they are to builders in their application. So very happy to be hosting the webinar today. Apologies, I have a typo on the slide. I have not corrected your name, Frank. The bio is correct, but we will make sure that your name is not Dan Sanding before we send this out. So my apologies there. I think many of you on the call will recognize Frank Lohmann by name. He is the Director of Building Science for the Canadian Home Builders Association and has been involved in codes as a codes employee before that role. So is very intimately familiar with this process. And Frank has tons of great insight to provide to us today on what the perspective of the Home Builders Association is, but also what the process of code development is all about, and can give us some insight into that. So thank you for being here, Frank, and apologies for the typo on the slide. And also we have Mike Memme, who is the operations manager at Mountainview Building Group. And Mike is on the ground building homes every day and has been a longtime friend of Building Knowledge and a really regular attendee at our spring conference, a spring training every year. Mike has been with the OHBA and also brings a lot of expertise in reviewing and being familiar with the policy direction of codes adoptions, as well as the actual application of those codes in the process of constructing homes. So thank you very much for being here with us, Mike. So before we dive into the content, a few rules of engagement or housekeeping for our webinars. We do have a Q&A section in the Zoom webinar. Please look for that Q&A section specifically for asking your questions. Unfortunately, because of our time constraints and the number of participants that we have on the call, which I see is up to 170 people today, so fantastic to see that. Thank you for that. Please use the Q&A to ask your questions. I will be monitoring the Q&A as we go through the webinar, and if any of the questions are really pertinent to the moment, we will try to get to them in real time. Otherwise, we do have a Q&A section dedicated at the end of the webinar. And as always, if we run out of time to get to all of the questions, we will do our best as your presenters today to do follow up with any answers that we can provide as best we can. The chat is reserved for technical support. Our BKC support crew is standing by if you have any trouble with audio or video or anything else related to the Zoom platform. Please put that sort of messaging into the chat, and Kim will do her best to jump in and support you as she can. Or if there's any other sort of general commentary, the webinar chat can be used for that. Please remember that the chat is not meant for advertising or promotion or solicitation. Any messages put in the chat in that vein will be removed. So we thank you for your understanding on that. We are recording the webinar today, and it will be available after the presentation along with the slides that we're presenting. And after the webinar, we do send out a SurveyMonkey survey to our participants to get your feedback on the session. What did you like? What could we improve? And what other topics are you interested in hearing about so that we can plan ahead for more sessions like this? And finally, closed captioning is available if you require a live transcript as we go through the webinar today. You can find the button to enable it down between the record and reactions buttons in your control bar at the bottom of most screens. Your experience may differ depending on your platform. So we would like to start by asking about you. If you could fill in the first two poll questions for us today in real time, we'd just like to know who is joining us from where so that we know our audience, always helpful as speakers. So our first poll will ask where you are tuning in from, and that should come up on your screens in just a moment. If we haven't captured your location on our list of options, please choose other and put your correct answer into the chat for us. And we'll give everyone about 10 seconds to fill out this first poll. Okay, 3, 2, 1, we'll call it there. And hopefully the results pop up on all of your screens, but I see a great diversity of attendance from across the provinces, which is great. A few from south of the border. Thank you for that. And it's great to see representation from BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, and the Atlantic provinces. Fantastic. Welcome all. So next, please tell us what keeps you busy. What do you do? What aspect of this industry are you primarily involved with, so that we have a sense of what keeps you busy day to day. And if we can speak to that role, that'll be helpful. Again, if your option is not represented, please use the chat and choose other to tell us what you're doing. I'm already seeing in the chat building official, modular builder, which is great. Building envelope supervisor. Excellent. Some Ministry of Housing, more building official, architect, great, welcome. And we'll give everyone about 5 more seconds on this poll before we move on. There we go. So certainly a lot of interesting answers in the other category in the chat. Have a quick look there to see who else is represented. But again, quite a diversity of attendees on the call today, which is fantastic. That gives us a really interesting cross-section to speak to. So with that, let's get into the heart of today's discussion. So as I mentioned, today we are talking about the recently published National Building Code of Canada 2025, which came out late in December, right under the deadline for a 2025 publication. With that document ahead of us, we have several of the key changes to review as we go through today. But I'd like to start off by just talking about where we are in the code development cycle. As many of you may or may not know, the National Building Code is developed in theory on a 5-year cycle, and there are several steps and intermediate stages along the way of every code cycle. It's useful, I think, to get a sense of where we are. So, Frank, I'll hand it over to you to take us through the next couple of slides, just to give an overview of the code process and where we are in this moment.
Thank you. Yeah, so what you see on this slide is essentially the 3 versions of the national codes that are playing a role as of today. So the top row is the 2020 national codes, which are, I see that we have a lot of people from Ontario. Yes, you are harmonizing, but you're probably the least harmonized among all the provinces and territories. But that code is currently being applied and enforced, and you see there the tiers, the energy tiers, which again in Ontario and are not adopted yet. In BC, there are steps, so very similar. But the code is essentially adopted and implemented in the process of being implemented and applied. The next line is the 2025 code. It is published, as Mark said earlier, recently, and we're in the phase of adoption. So you'll see there between today and exactly June 2027, we would expect that every province and territory, or actually they committed to adopting the national codes within that time frame and no later than mid 2027. And what you see there is similar to the energy tiers in the national codes in the 2020 version. In this version, we have levels of GHG level implementation that will be staggered. There is 5 or 6 or 7 levels even in the code. And it's expected that provinces and territories will progressively move to more ambitious targets. And what you see on the bottom is the development of the 2030 codes, which has already started. And the little red dots there, the milestones are the public reviews that have been scheduled. I think it's 8 of them. So 8 public reviews, they're each 2 months long. So that'll keep my team busy because we're going to prepare comments and feed them to the CHBA members for input. And then you see the blue milestone there. That is the last possible technical change that can still be entered into the system before it makes it through all the changes of committee deliberation, public reviews, revision, and approval before it gets published. And if you look between that blue milestone, which is, I think, spring 2028, and the adoption of the 2025 codes in the above line, which is mid 2027, that's only, it's barely a year, okay? So from applying the 2025 codes, if they all get adopted, to making sure that the last error could be corrected, there's less than a year time. So it's very, very narrow. It's a continuous code development. They're going to be continuously developed, and that's where we are today. So we are, as a community, code users community, the 2030 codes, while we are watching what happens with the 2025 codes. If you go to the next slide, I'm going to lead into maybe some comments I make. So one thing, and you can see here, I presented this in February because I haven't updated my timeline where we are today. What we're a bit concerned about is this cost overlap of, we haven't even seen the cost being incurred for the 2020 codes moving up to the tiers or steps to the highest level. I think BC's at step 3 or step 4, I'm not sure. But so as those costs are still occurring between 2027 and 2030, the other code, the new 2025 national codes are being adopted, and all the changes and the cost associated will overlap with the tiered cost. And just a note, and maybe you can go to my next slide, because that is the perfect segue to some comments I'd like to make. CHPA has done a back of the envelope estimation of the cost for the 2025 codes in total on one archetype and overlaying the segmental, like the progressive cost of energy tiers, and we've come up to over $100,000 if you overlay them and if you apply today's labor and material cost per home. And that's a significant number. I mean, I'm happy to discuss that with anyone. Cost estimates are always fun because everyone comes up with something different, but that's the number we come up with, and we think it's very significant, which is one reason why CHP, and by now, I think you may have heard, we wrote the letter to the Prime Minister saying this cost is too much. But it's not the only part that we're worried about. There's a lot of systemic issues. Mark mentioned earlier in his slide, yeah, there's going to be a lot of changes coming on a faster pace. More significant topics are coming than the ones we're discussing today. And so at the same time, the code system on the national side has changed their governance. They've changed the process. There's still no unified national interpretation system that could be used to make sure that we don't even interpret the code different from city to city. And there's still no limit on any cost changes that any codes committee could ask for, and we feel the industry voice in all of this is being marginalized more and more. So those are the issues why we wrote. It's not just the cost. The cost may be the most visible. So anyway, none of this is the topic today. I just wanted to mention that because some people have been discussing this on LinkedIn. And the commentary I'm going to make today after each of Mark's slides and the topics and Mike's is essentially telling you why we think some of the changes that are in this code are good and we support them, and others are very problematic. And so what we'd like is a conversation with the governments, the provincial and territorial governments, to say, look, we don't mind adopting cost neutral changes or changes that correct errors, obviously, because they make our lives easier. They will allow us to build more homes. But those problematic, very significant changes for which we need new education and more material, can we please pause them? So anyway, that's where I stop my soapbox, and sorry for the advocacy, but that's really what's the basis of my commentary on the technical changes. Thanks, Mark.
Thanks, Frank. I think it's an important stage to set, and it really does, in my view at least, highlight that there's merit to understanding what the changes are that are published and what they look like and getting familiar with them, even while we talk about the challenges that we face on the development and policy and governance side of things. They're not really separate from each other, but certainly both have merit. And I think sharing the CHBA's very public perspective on this is great to hear. Mike, any reaction to that from your perspective? Anything that Frank said or the timelines that we've looked at so far?
Well, there's so much there to unpack, and I think maybe my thoughts on some of this will be better shared as we get into some of the details of what's in the 2025 code. But maybe from a high level, Mark, I've been around for a long time with this, and I look back at the glory days of sitting in a room reviewing proposed code changes as a builder with engineers and architects, and talking about the pros and cons of the items line by line, with MMAH sitting there listening to and participating in the discussion. And I just felt like we did excellent code work. I have to admit, I'm surprised that there are no site supers on the poll here. And the number of builders is small compared to the other people that are part of the seminar. And why are builders not getting their site supers more involved in this stuff? And I feel like even in the whole code development process, the people who are actually implementing the codes have lost their voice. And I'm not going to go any further than that, but I'm a builder. I work with a team, boots on the ground, and there's something not right. And everybody looks back at the past like those are the glory days, but there is definitely something missing. And as we get into the details of the items, I'll be able to share some of my thoughts on that further.
I think that's a really nice foreshadowing to our call to action at the end of today, which always, when we talk about codes, is about getting involved, about sharing these perspectives at the level of the code development process. So I'll leave that teaser there, and we'll have a chance to talk a little bit more about that at the end. So let's get into it. What are some of the changes that are included in the NBC 2025? and what do they look like. There's going to be a range here. I should preface this by saying we are certainly not covering them all. Please don't treat this webinar as exhaustive. There are, as Frank alluded to, several changes that are unrelated to energy and greenhouse gas emissions that are still very important to acknowledge. And we didn't even venture to compile a list for you because didn't want to miss one and be liable for that, let's say. So we will talk about the ones that we've included. And some of them are very straightforward and others less so. One of the ones that is fairly straightforward, at least to understand, is the introduction of a requirement for passive stacks for radon. I'll just mention for the benefit of our attendees that on these title slides, I've included the PCF number of the change. And for those of you that aren't familiar with that acronym, PCF stands for Proposed Change Form. And it is the document that describes the change under consideration during the code development process that is then adopted and written into the code language itself. They're all ascribed a unique number. And if you want to go and get a concise description of the change, rather than trying to comb through the code language to identify it in context, you can actually very easily find these now by doing a PCF 1713 Google search, NBC 2025, and it should take you to the code's website that has a PDF for the change itself. So when we share the deck after the presentation, if you want to go and look more in detail at any of these changes, that's your cheat code, if you will, to go and find the description of the change. So many of us are already familiar with what radon is. It's a colorless, odorless gas that comes from the soil and can infiltrate our homes, especially basements. And it's the second leading cause of lung cancer following smoking as a cause of death across Canada. There are some published thresholds that are deemed to be safe, so to speak. 200 becquerels per cubic meter is what the Health Canada guideline is. But we certainly know that with any sort of carcinogenic or harmful gas, less or none is always better. So the existing National Building Code, when I say existing, I'm going to be referring to the 2020 NBC, which has been harmonized in several provinces, or at least partially adopted in many, does already have provisions requiring a soil gas barrier, which can be read as an air barrier separating conditioned space from the soil, and a rough-in, a subslab rough-in for future radon gas extraction systems to be connected to. But the research shown during the development of this new requirement acknowledged that a properly constructed passive stack can substantially perform and augment the reduction of radon levels, which was put forward as a more cost-effective and reliable method than retrofitting later. Now, we'll maybe have a little bit of debate on that. So what does that really look like? Well, the requirements that were already in the code were for, as I mentioned, that air and soil gas barrier, equivalent in performance to 6 mil poly. The rough-in, and you can see some images of what that rough-in looks like or could look like, a few different options for that, which is in the sub-slab layer, a gas permeable layer with an inlet or outlet and a pipe for connection that was labeled. But the new requirement is to actually connect the vertical stack, which will take that rough-in connection through the house and out through the roof in order to exhaust radon passively as a methodology. There are some concerns that this is inflexible and maybe limited in its scope. And Frank, I'll pass it to you to maybe offer your perspective on this change and how you see that potentially limiting builders in their execution.
Yeah, thanks. I was just already opening my building code for some of the questions in the chat there. Yeah, so I think that as you mentioned, the air barrier, the sealing and overlapping of joints in the soil gas, or we call them air barriers, air to the ground, right? That's a very good change. I think on the walls, we do it routinely with the acoustic sealant or the tape that sticks to the poly. If you use poly on the ground, you can use the same thing. I haven't confirmed that with any authorities, but that's typically how it's done. The polyethylene used to be in a standard where it said not for below ground applications, but that has been changed. So that problem has been taken care of. So we think that's a positive change where we share the concern, Mark, is what you mentioned, passive stacks. The first bullet here is actually a non-technical concern. If you build a passive stack and it vents radon and it may give a false sense of security to a homeowner saying, oh, my inside radon concentration is acceptable as of new construction. That is not the case. A passive stack doesn't have a fan. I can tell you a story of my own house. When I moved in and we measured the radon, we had levels of 6,000 becquerels per cubic meter. And you said the limit is 200, right? If I had a passive stack that would have reduced it by 90%, I would have still been, way too high. So it isn't acceptable radon indoor concentration. So that's our first thing. I think we need language somewhere that says it is ultimately the homeowner's responsibility to measure for radon and make sure that there is an acceptable level of radon in the house. But you said it only applies to 7% of the houses. That's our next problem. Why treating 100% of homes if only 7% are the problem? Anyway, on the technical side, passive stacks are not possible in all home layouts and all housing forms. So we had hoped, and we communicated that earlier, that we needed other forms, other mitigation measures, and they are available. The standards, I think you mentioned them, CGSP standards for radon, they have all these measures. So the other issue with the passive stacks is that it's a pipe that goes through and it needs to be insulated in the attic space, for example. That's a lot of insulation there. And because you're drawing cold air from the ground all year round, there may actually be condensation on the indoors. So that hasn't been looked at, especially when you put in a fan. So those are the things that are not even with the passive stack requirements are clear. There is some guidance in the standards, but not in the code. So the other things that are missing is if you have an existing home and you're mitigating radon, you can vent out the sidewall, which is perfectly acceptable for existing homes. But the committees were not willing to make that an acceptable mitigation method for new homes because it would have had to be capped, right? Because a passive stack going out sidewall from your ground floor to the side obviously doesn't have enough stack effect, but it could have been capped and labeled, and then it would have been ready to put a fan in the same way. It would have also been clear that it is the homeowner's responsibility to measure and make sure whether or not a fan is needed or not. So same with the active mitigation. You can't just put a fan in. You actually have to make sure that the fan really reduces the radon to an acceptable level. That part wasn't even put in the code. And there's now discussion for the next code or even an interim change on an active light where people put in a fan regardless of the size. And we think that's even worse. Even the radon mitigators are arguing that would be really the wrong way to go about it because there is a simple way that they use to make sure that radon indoors is acceptable. And I don't want to minimize the risk of radon. It is there. It is one of the biggest lung cancer causing, even though it really, there's no clinical proof, right? That if you're dying from lung cancer from smoking, you can see that on an X-ray. If you have a genetic cause, that can be proven in your blood. Like for radon, lung cancer deaths, it's a statistic number. You mentioned it earlier, 16%. And so just a word on statistics. If suddenly everyone in Canada stopped smoking and our lung cancer numbers would go down as a total, those 16% would also be lower. But not because we mitigated radon homes, just because we have a total number that is lower. So my biggest problem is we will never know whether our radon mitigation for homes will actually improve the number of radon lung cancer deaths because we have no direct link. It's a statistic, it's an assumption, 16% of lung cancer deaths in 7% of the homes, but there's no direct link, so we can never prove it. Anyway, that's how I leave it. I'd like to have a discussion with an epidemiologist one day, but it's probably out of scope for this. Oh, and on the bottom right, you see for CHBA members, if you go to our knowledge center, we have a tech essential that explains in 2 or 3 pages what this change is all about, all the important terms, and we are working on a backgrounder as well.
Mike, your perspective on this change.
Well, before we even get into the vent pipes, I think there could be, with this code change, some discussion about the sealing of overlapping joints. And Frank, like, are there approved tapes for under slab that can be used, or are we talking about acoustic seal between overlapping joints? And then even if we're talking something like Acoustiseal, where the joints overlap, you can't use that to connect poly to a plumbing penetration. And I think building officials and builders are going to have a little bit of work to do. And this is one where I could see different rules applying in different cities. Any comments on where we are with approved materials for sealing?
No, there's no approved, at least in the code, there's no, use this product or something. What would typically work is if, for example, for those manufacturers that have an approved radon barrier, which by the way are much thicker, they will have an approved method of sealing them with either a tape or a sealant. And I don't know what the composition of those components is. For more commonly used, for example, the polyethylene, there are manufacturers who offer a tape, and you've probably seen that red tape that actually sticks, and the acoustic sealants, but none of them are approved sort of by a standard or something that links to the product in the code. There may be a source of CCMC, and Mike, I haven't looked that up, or I haven't followed up with CCMC. There may be manufacturer systems, air barrier systems that come with your air barrier material and a component that seals it. And so certainly speak to your manufacturers of your air barriers and soil gas barriers, and they will be able to tell you what's compatible and what's actually sealant. And I mean, you still have the weight of the slab pushing it down as well, right?
And I don't think like that's going to get as much attention as the passive vent stack, but it is going to be a potential point of friction between builders and the building officials. When we get into the passive vent stack, as a builder, we've installed some passive vent stacks as a test. The bends in those stacks, like I think maximum 22-degree bends, trying to make that work in an open concept townhouse was extremely difficult. It's very expensive. I'd highly recommend that if you've not installed a passive vent stack that meets these requirements, whether or not they're applicable at the current time, you got to install a few of them. We did like 5 different styles of houses just so that we'd understand what we're dealing with, and I'd highly recommend that builders do that. But as a builder, one of my biggest areas of concern is ceiling penetrations, and I know that ceiling penetrations are easy to deal with and to seal properly, but just in the field, it doesn't always happen. We see lots of spray foam trying to attach poly to pipes using spray foam and stuff that just doesn't seal. It's the most important barrier in the whole home is the air tightness of that ceiling air barrier, and just the active light going out the sidewall, add a fan if you need it. The fact it didn't get into the code is such a disappointment, and this is something that we've got to work on. But yeah, for builders, install some passive vents, get a feel for that. And you've got to look at how you're going to see. These are bigger pipes, and you've got to look at how you're going to seal them for air tightness in your envelope.
Yeah, so I really like that message, Mike, of, give it a try, see how it fits with what you're building. But as you were mentioning, Frank, certainly room for some advocacy for options, some alternative solutions to give us more flexibility in that. So lots to dive in there. I do see some questions coming in, but just knowing that we've got so much to get through, I'm going to suggest I'll leave those to the end, and we can always revisit these topics with those questions. So please keep the questions coming. I am seeing them, but we will keep pushing ahead just to make sure we don't leave anything behind. Okay, moving on to our next proposed change, and this is combining 2 PCFs into one discussion. Both have to do with the protection of rough openings and the extension of the second plane of protection into those rough openings. So the PCFs that we are referring to for this change are 1950 and 1951. And really what these changes are trying to do is to address an inconsistency with the way that the code language spoke about the required sealing for rough openings in very much the same way that they spoke about the requirements for sealing of penetrations. And that was to treat them all as a face sealing problem. For those of you that are, really quite familiar with the idea of a second plane of protection, we know that it is the part of the house that really needs to reject water back towards the exterior. It is what deals with all the water that gets past our cladding and gets past our window frames in the first place. And when we start to look at what happens at a rough opening where a window or door is installed, we can recognize that there is actually a very important step to extend that rough opening into or extend that second plane of protection, excuse me, into the rough opening itself, so that any moisture that gets into that space can be redirected out. Sealing at the face alone doesn't do the job, and in fact has led to some misunderstandings about the intention and the way we're trying to seal windows, where somebody very well-meaning in this example would have taped across all four sides of the window, sealing it to the weather barrier, trying to make a barrier to water and to air. But after only a short period of time, if you peel back that weather barrier, you see that in fact there has been substantial damage and deterioration caused by water that is getting past that barrier and not having a pathway back out. It's being held in the wrong part of the assembly and causing problems where we really don't want those problems to be. So the concept here, which has been a best practice for a very long time, and in wet locations like in parts of BC, has been executed for a very long time, is this idea of water will get in to these openings. How do we make sure that it can come back out so that we don't end up with problems like that? So the two changes sort of try to address related ideas around this concept. The first one, protection of rough openings, still points to the CSA standard A440, which is a CSA standard document that describes the protection of rough openings and the requirements around those. And the change in the NBC 2025 is that there are fewer exceptions to the language of that standard. The standard remains pointed to, but some of the exceptions that were being allowed in the code have been removed. And really what's being asked of builders is that sill protection be installed and the rough openings of all windows and doors, and that the interface of other assemblies with your weather barrier can be done at the face, but really at rough openings, we need to turn that back into the depth of that assembly. So this slide and the next slide, I think, show the actual language coming into the code right here. So there is an extended appendix note for this change in the code that explains the intent. Now, code language is very particular in that appendix notes, which are included for clarity, are not enforceable. So it's important when you're reading a code change to ask yourself, does the code language itself give me the clarity that I need independent of the appendix note, even if the appendix note helps with my initial understanding? Because a code official does not have to look at the appendix note when making an interpretation of the enforcement of the change. But what we're really talking about here is actually something that I think has been quite well done in the appendix note. They've included a lot of very clear graphics to explain the requirement for extending this protection into rough openings. Some of the best professionals in our industry, like Darrell Paul, worked closely with the CSA on that standard and including some of these changes in an illustrated way into the appendix note for the code to give clarity on what this is. And you can see in the diagrams that extension of the weather-resistant plane into the rough openings with the arrows directing the path for water back out is the key component of this requirement for extension of sill protection in PCF 1950. Now, what has become a really hot topic for discussion is the change in 1951 around continuity of installation, which introduces the idea or the exception allowing builders to install a lower level of insulation on the sill of a window than on the other three sides, and possibly as little as no insulation at the sill, because they are trying to prioritize drainage over that thermal condition. Now, there is some research out there, and I think we'll talk to it in a moment, that indicates that if you do a proper job of air sealing the window at the interior plane of that window, that creating a dead air space underneath the sill does have insulating properties. Now, you have to get it right in order for that to be true, but the example that I've been familiar with is if you try to blow air into a pop bottle, for example, because the air has nowhere to go, it's not possible to do. So as long as the air seal is continuous, then you have substantially addressed the concerns here. But the main thing to take away from this is that the allowance for a reduction in insulation at the sill is directly the result of trying to ensure that the drainage pathways below the window back to the exterior are left unimpeded and that we're not accidentally blocking them with poorly applied products in that space. So the appendix note for this change does try to introduce some clarity in that, but certainly this is going to require us to take a close look at our window installation details to make sure that we are not inadvertently causing a conflict with either of these changes as we go forward. So Frank, I'll pass it over to you for the CHBA's perspective on these two changes.
Yeah, they're very much aligned with your presentation, actually. First of all, I think we've asked, I can't even say we, CHBA, because in 2014 I was still at NRC, but I remember that CHBA staff was asking, especially with the advent of bigger building envelopes for energy purposes. Like we knew that we would get bigger and bigger in terms of the envelope thickness that we have to span. So we said we need to resolve this water ingress problem for high performance envelopes. And so that change, I think, is very well done, as you explained, with good drawings. I mean, there's always perfection, but I think they're much better. On your slide, the picture in the middle was the one that's currently in the code. Yeah, that one. You see, it's red around it, which means in code language it's being taken out. So that was the previous, and what you have around it is the new guidance. And I think that's a major improvement to just see, here's what we're talking about, right? So it's good accepted practice. We have it in the CHBA manuals. You may know it from the LEAP training on window. What we're hearing on the moisture protection is there may be some trade sequencing and project scheduling issues because there isn't the window installer will not do it because it's too late by the time they arrive. And the framers are often not equipped to do it. So if you have an air boss in your crew, maybe you need to expand the scope a little bit. They can also do the barrier boss now, something like that, or a flashing boss. I don't know, but that's what we're hearing. So it just needs time to try it out, as you said, Mark. And I think it's a great idea. Get going, try this out, see where the challenges are, which tapes stick, which ones don't. And there's lots of videos out there, including from Daryl Paul, lots of resources. The insulation at the sill is a bit more problematic. I agree with you there too. We've heard during our public review comments when we collect feedback, especially from the northern areas in BC, Alberta, and also in some cases in Ontario, that they have already seen condensation at the bottom of the frame, and that's why they do not leave it uninsulated. So, and Mike, I think you can add to that. One of our biggest pet peeves is we've asked the committee at the time before approval to review the research from its own researchers on condensation, and we don't think that happened to any level of due diligence. And lastly, I think you mentioned the CSA 440.4. Yes, there's few exceptions in the code, but we still think there is inconsistent language and potentially conflicting language in CSA 440.4 and in the code. So because CSA 440 still requires all four sides to be insulated. Maybe I'll pass it on to Mike or because I think you have more color commentary on that.
Yeah, a few things. First, to start off with, in my experience, I've been building for a while, and a multi-light casement, if you've ever taken a close look at, in our market, we're mostly vinyl windows with wood jamb extensions. And if you take a close look at a multi-light vinyl casement window, it's three vinyl pieces that are all welded quite nicely, but then attached with mechanical fasteners. And these things do leak over time. And how they're sealed at the front, we've seen where the little strips that hold these pieces together, they were installed missing caulking and stuff. Water gets into the penetrations with these. It's something that just I saw quickly with Mark's slides that I don't know that I caught before. Do we need sill protection only with multi-light windows? Do we not need it with single light windows? Will people catch that? But then, even into the whole conversation of the sill pan work, we at Mountain View, we've been installing sill pans, I think, since about 2000. It's required, but not required. Building officials aren't looking for it. it's just something that you have to do as a builder. But when we look at the bigger picture and from the builder's perspective, one of the trends that I've seen over the years that's become quite popular is moving the air barrier to the exterior face of the wall construction from the interior face of the wall construction. And if you have a sill pan flashing at the bottom of your window that you've left open, you have to recognize that your exterior air barrier moves to the inside, because Mark's pop bottle, the back of the pop bottle is at the inside. And then how do we even attempt to get the trades to understand that their exterior air barrier actually moves back to the inside at the perimeter of every window? And then, Frank, you touched on it, and we've experienced this. Like we did a mid-rise building with vinyl windows with wood jamb extensions. And we decided to do the ultimate in air sealing around every window. We put backer rod and caulking because we wanted our pop bottles to be super tight. And and then we had no other spray foam or anything in the windows. And we experienced condensation where the vinyl meets the wood. And I don't know if it's because it's cold and the pop bottle scientific explanation wasn't working as intended. Or is it just that where the wood jamb extension pops into the vinyl, snaps into the vinyl frame, it's not perfectly airtight, and there's the smallest amount of air movement. So we've got holes in the bottom of the pop bottle, which allow the air to move through, and then the whole thing gets super cold. And so then in later buildings, we're spray foaming all four sides with, in our mid-rise anyways, with backer rod and caulking. That's belt and suspenders. But even on the low-rise side, where we're not using the backer rod and caulking and spray foaming all four sides, that spray foam, I think we give it more credit than what it actually, how it performs, because I feel like air gets through it and so does water. And we've not been having window issues with it on four sides with our sill pan. So I'm struggling with this. I really hope I can just keep doing it the way I am. But for the builders out there, you've got to start doing, like you should be experimenting with sill pans if you haven't already. Whether this code change gets adopted by Ontario, you should be installing sill pan flashing. Like it just makes sense. But then there's that whole thing, like how do you train the trades to recognize where the air barrier is? And that face sealing at the bottom, we're very proactive and we do a lot of work with our trades. And I still get siding and siding trades and mason trades face sealing the bottom of windows when we have a sill pan flashing right there. It is just so difficult, and I feel for builders that are struggling with this. Get that sill pan flashing in, and not worry about what the code says, so that you're already prepared.
Good comments.
Yeah, so
Yeah,
Mike,
definitely. Go ahead, Frank. Go ahead.
yeah, I just took a note of your question there, whether it only applies to multi-segment windows. I looked quickly in the code. I can't find that it's limited to that. That may be something in an earlier proposed change form,
Yeah,
but I will confirm that as well. I took note of it, so I don't know the answer.
thanks, Frank. It's really good commentary, and I think the takeaway that I have as well is that last change, the allowance for reduction of insulation at the sill, is not a requirement for reduction of insulation at the bottom of the sill. So I think there's an opportunity for us collectively to re-examine our window details and see, as you said, Mike, is what I'm doing now okay, or do I need to make a change? How does that affect sequencing? I think that's the message we take away with all of these things, right? We look at what we're doing, see where we stand. I'm going to keep us moving. We've got 4 more changes to get through. So we'll stay on the topic of windows. An important change here with PCF 1823 that introduces some really key and I think desirable improvements over the last version of the published code. So we'll get right into it. The first tries to address the risk of introducing overheating into the house because we're trying to take most advantage of solar gains without necessarily recognizing their impact on comfort and the impacts of the occupants. And so the energy modelers on the call will know that when you put in higher solar gain glass into your energy model, your total energy goes down because you're getting that free heat from the sun. But we know that peak cooling demand goes up and the air conditioning loads increase, and the risk for very specific moments of occupant discomfort that happen quickly goes up. And so currently, the National Building Code 2020 tried to address this with a requirement to the performance path that your proposed house must have a peak cooling load lower than your reference house. And this was very restrictive because the reference house used quite a low solar gain house. And there's a little bit of a semi-famous anecdote. I think it was Mark Bernhard out here in BC analyzed Santa's house at the North Pole and found that it would fail this restrictive overheating limit. So it was very problematic in the performance side because the measure trying to address this problem was too restrictive. On the prescriptive side, there was no limit to the solar heat gain coefficient that you could use. And in fact, because ER in your window selection or energy rating in your window selection was an acceptable compliance pathway by itself, this in fact sometimes pushed builders towards higher solar heat gain problems. And following the prescriptive path could then lead to some overheating problems. So there was a risk of projects being out of compliance or in non-compliance despite intending to meet the code or showing intent to meet the code. And there are some examples on the slide of homes that were facing some problems. And so some really fantastic work was done in collaboration with the window industry and the committees working on this problem to recognize that in the prescriptive path, when we were just choosing from a checklist of measures to do, there needs to be something to address the risk of overheating. And that was introduced as a upper limit to the solar heat gain coefficient that we use in our windows based on two factors. Number one is the fenestration and door to wall ratio, the FDWR, of the whole building. And this was an important change. If you're familiar with some of my presentations from a year and a half, 2 years ago, it was initially proposed that this would be by orientation, but it was recognized that the complexity compared to the benefit of that in the prescriptive pathway was not useful. And so we are going on a whole house fenestration door to wall ratio, which is very familiar because we see these numbers. For those of you in Ontario, these align with sort of the thresholds that move you into different compliance requirements. And then the climate zones are the other requirements. So as you go into colder and colder climate zones, higher gain windows are permitted because they are the scale starts to shift from problematic to beneficial as you get into colder climates and take advantage of that free solar gain. So this table is in the 2025 code and gives you in the prescriptive side your requirements for complying with that new solar heat gain limit, which I think is a plus. It's a very good move. On the performance side, some really great work was done to look at that restrictive requirement and to extend further options. This is in the theme of flexibility of options. And so the same requirement remains if your proposed house is lower than the reference house in its peak cooling load, you are still deemed to be in compliance. But there's a second method introduced that introduces a design cooling intensity related to the new energy use intensity metrics pathway, which we'll get to next. Or, and this one I think is really where the success was, taking some cues from the CHBA's net zero program. If there is a mechanical cooling system installed that has been sized using the CSA F280 standard, then that is deemed to be compliant in the performance path as well, which gives builders a lot of flexibility to use heat pumps, for example, to represent their impact on the energy side of the equation and to be in compliance with the overheating requirement as a result. So we'll maybe take about the 3 to 5 minutes to talk about this change before we move on to the next one. I'll hand it over to you, Frank, for your perspective.
Yeah, very quickly. I mean, you explained it all, and I agree. This was an excellent piece of work. CHBA had identified these issues even before the 2020 codes were published, but apparently they couldn't be done before. I mean, just to name a few, like as you said, air conditioning wasn't even recognized, but the peak cooling criterion was one of the 3 mandatory checks for tiered codes, right? So on the slide on the bottom there, you see what we did is CHBA's net zero homes, we analyzed where would they have fallen on the peak cooling criterion, and we found a 50% of compliance rate, which is also what Mark Bernhard found. It doesn't depend on climate zone. It was really like even if you have if you had a well-designed home, it would make it difficult to so all these things. I think there were 7 points. We had a backgrounder. CHBA members can find it on our knowledge center still. And I think all those points have been addressed on the prescriptive and on the performance side. So we're very happy about that. I would also note the strong collaboration with the fenestration industry that modeled all of this, the pluses and minuses, as you explained. I mean, if you have a higher solar heat gain coefficient, you gain more heat in the winter, but you lose it in the summer. And as we're moving to a cooling climate, and many Ontario areas were already in a cooling climate, that balance needed to be done, and they did it for a lot of climate zones. So that's what created that table. A really good piece of work. And I think in the discussion of the committee that you mentioned, and in other committees that we're talking now about overheating control, we're talking about potentially adding solar incident data to Appendix C, which may then actually give a real metric in the code to design for overheating. But that's an overheating topic for human safety rather than to make sure what this change was doing, that it did try to limit the risk that very energy efficient homes add to the overheating risk, right? So that's what this was all about. So very happy about this. It's a good change.
Yeah, and I think that's an important distinction that is actually in the PCF directly, is that this does not solve the life safety concerns that we saw with the heat dome in BC as in extreme climate events, as you mentioned, Frank. I think that's appropriate. Mike, any thoughts on this one and how this might impact what you do?
Not difficult for builders to implement. It's excellent work that was done to get where we are. No further comment. Yeah.
Easy now. So yeah, I like this change in particular because I know sometimes when we start to talk about changes to code, we think it's all bad news. I think this is a really good news change that gives us flexibility and positive influence. So happy to
Yeah,
bring
if I may add one thing, Mark, you're right.
Please do.
This is one thing that fixes something that was really not working. Anyone who is still dealing with the 2020 codes, I mean, if there's some people from the prairies, I think you may have adopted this and you may be challenged with this. You could bring these changes to your government and say, well, if you don't do anything else, but please put this in because it fixes the 2020 issue, right? It makes it much more feasible to comply with a decently designed energy efficiency product rather than being penalized for, you know, having one joule more on your reference cooling than, or the other way around on the proposed cooling. So this is a really good change and would affect everyone that's currently dealing with 2020 codes.
And a comment on that that I can't stop myself from making is this is helping fix something that was pushed through on the 2020 codes. We have the energy piece where the additional points through the prescriptive system helped fix problems from the 2020 code. As we continue our cycle, are we going to keep looking back at previous codes and adding more and more fixes to what wasn't executed elegantly the first time? But I'll leave it at that.
Fair enough.
We'll take it.
So our next topic is there's too many PCFs to put on one slide here, but this is really acknowledging all the work that was done to improve and extend the prescriptive path points-based checklists that are part of compliance with the tiers. So for those of you familiar with Energy Star, you'll already know how this sort of works. The points system in the code gives you a list of measures. And depending on how far you go with any of those measures, you get points towards a total number of prescriptive points that you must accumulate to demonstrate compliance with the tier. The first thing to be aware of is that they finally published targets for all 5 tiers in the prescriptive pathway. And this was missing in the 2020 code because the work had not been completed to generate enough points to get beyond tier 2. Now we have that. So now the points totals required for each tier are shown on this slide. It's important to note that the Tier 4 and Tier 5 prescriptive pathways now do have a minimum air tightness level associated with compliance with those pathways. We haven't seen anyone harmonize at that level yet, so we don't know what that looks like in practice, although BC does have mandatory blower door testing as a part of their STEP code, so there's a little bit of learning to look at there. On this slide, you'll see several PCFs listed, which show where additional ECPs or energy conservation points were added for various ECMs or energy conservation measures. We love our acronyms, so I'm going to keep using them. But there are new points available or additional points available for drain water heat recovery, for HRVs and ERVs, which include more credit than they used to get. Additional points for fenestration and door selection, building envelope measures, some provisions for certain areas of Canada related to upgraded oil furnaces, and air source heat pumps and other ways of calculating the percentage of the load that they serve are addressed in the prescriptive pathway as well, giving us many more areas to accumulate points, sometimes for things that we were already doing that the code just hadn't recognized yet and hadn't given points to. And a couple of the other things that are coming, this was an error. The air tightness tables in the 2020 code were reversed. the guarded testing table was where the unguarded testing table should have been, and vice versa. That has been corrected, and the points have been updated as a result. And in many of the categories, they've also introduced the ability to interpolate between published points on the table. So with walls, for example, here's a little example. If the wall that you're planning to build falls between two of the thresholds in the published points table, in this case, our wall is a 3.39 RSI. You see that falls between 3.08 and 3.69. We can actually use the interpolation formula now to get points from halfway between. You're no longer limited to getting the lower number of points. You can actually split the difference, and that's going to give us a little bit more flexibility and full credit for the measures that we are taking, and be a little bit less sensitive to things like a cladding change that would bump you down out of a prescribed level. So this is another good news story. The proliferation of points gives us more flexibility and makes this prescriptive path more usable as we target higher tiers. I think the interpolation was a really great thing to see come through. And knowing that the upper tiers are protecting these highly insulated assemblies with an air tightness testing requirement, I think although that is another cost that comes with those upper tiers, is an important building science consideration for protection of assemblies that many people are in favor of. There are also now prescriptive packages published for Tier 5 and Tier 1, and work is ongoing for the intermediate tiers. And this is more aligned with what those in Ontario will recognize from SB 12 as a prescriptive group of measures that you can apply together to be deemed in compliance. They started with Tier 5 in part because there was a lack of points to go with the other pathway, but the work on these is ongoing in the current code. I won't go into depth on these, but in the slides that you'll receive afterwards, we do have an example of what a Tier 5 prescriptive home might look like. And so I'll let you dive into that in more detail. But I think there's some good news here as well, Frank.
Yeah, certainly agree with you in this assessment. Great. And in Mike's word earlier, to have completed the 2020 code, right? We would have loved, and they actually weren't very far to add at least a Tier 3 or Tier 4. At the time they published the 2020 code in 2022, which would have been really good. But anyway, it's a positive change. It gives options. I think even some provinces like BC, Quebec, and Ontario may have potentially adopted the tiered codes if this had been complete, because there was no complete prescriptive method. And Ontario, I remember, was very interested at the time. I mean, I'm not going to put words in their mouth, but anyway, this could have been done better if we had code development in mind as a wholesome, let's take one solution, finish it, and then put it out, rather than in bits and pieces over 2 or 3 code cycles. So it's an excellent method. I agree with you, Mark, for builders to understand what is in play, and even for the builders in Ontario or in BC with step codes, or in Ontario with builder option packages under SB 12. See where you end up. Try out a Tier 3 because that would maybe be the next step forward for many Ontario builders. How much is actually involved? And especially if you're a prescriptive builder and you don't have worked with an EA yet, this is an excellent way. We do have 2 documents out. One is actually, it's the same document. I just put 2 screenshots on the side there where we have some examples of homes and how to do the calculation in that backgrounder. And the last point, you mentioned, you implied it, Mark, but I want to make it very, very clear. This is a prescriptive method, and air tightness gives you a lot of points, but it doesn't give you any points if you don't test. So it's not mandatory, which is great. You can also over insulate and not, and keep an air change of 6 or 7. I don't know how that works. But you don't get any points unless you test. This is an excellent opportunity to get a hang of how to test, get some of your crew certified as an air testing technician, buy your own blower door kit, figure out how to get to a lower air tightness and see if you can get any of those points. This will be the biggest bang for your buck, especially have your own quality assurance internally. I didn't put that on the slide, but I realized when you said, air tightness is super important. I think this is trying this out, playing with it on your own, see where you can get points and where your next step and how close you are to the next tier. That would be great.
Mike, thoughts? Excited about this?
You know what? So as an Ontario builder, we're SB 12. And until we have to look at something other than SB 12, we're SB 12. Like orange is the new black, 936 is the new SB 12, but will I have to deal with this? When will I have to deal with this? Ontario right now, like the provincial government has said that they want to do a line by line review of the code and try to remove as much from the code as possible. So what does that mean for adoption of 936 from the national code and it one day replacing SB 12? Will we see this or not? So, I think as an Ontario builder who's done a little bit of digging into 936, first thing is, if you're a builder or you're an architect working with builders, understand what 936 is and take a look at it. Um, you need to prepare yourself for it mentally in some way because like one of my biggest fears is that the code development cycle progresses. We have an election, we get a change of government. Next thing you know, 6 months after a change of government, I'm 936 and I don't know what's going on. And from Mountain View's perspective, we've run some of our houses through 936 to see how close we are to tier 3. And there's not a lot for us to get to tier 3. So I'm not afraid of tier 3. So, as a builder, I've got two pieces of advice. First thing is hire an energy evaluator just to do one house and see how you compare to 936, the national code tier 3, based on prescriptive packages and based on performance approach. Just get that information just so that you know where you are and you have a baseline in case a change comes quickly and unexpectedly to harmonize in that way. And then the other thing I think I need to say to builders, if you predict that your career in home building is going to last over 5 years, start doing blower door tests. Like all the Energy Star builders are doing it, all the net zero ready builders are doing it. Do those blower door tests, find out where you are, get used to the idea that you're probably going to have to do blower door tests on all houses at some point in your career, and you're going to have to hit a certain level. And, both Mark and Frank talked about it. Investigate 936. If you don't even want to look at it and understand it as a builder, get an energy evaluator to help you and just show where you are. Do some blower door tests. Get used to the idea of doing them in all your houses. And you know what? The other thing about blower door tests, they help you meet these energy efficiency requirements so that you can meet certain levels of the code. But I think the biggest thing about blower door tests, when your houses are tight, you've got a lot less risk and a lot less issues potentially for major issues with these homes that you're building.
Yeah. Okay, into our last three changes that were presented today, and I got to say, each of these is probably big enough to be a webinar of its own. So we'll do our best to move quickly through them. Thanks for your commentary, both. I know we could probably add a half hour to this webinar. Maybe we'll stay for a few extra minutes to address some questions if you're both okay with that. The first of these last three changes is that there is a new energy compliance option called energy use intensity metrics associated with PCF 1869. And as I mentioned, this is quite technical. There are some formulas to get into that we don't have time to get to today. So what I want you to take away from today's webinar is that this change was introduced to address that certain housing forms are very challenged in demonstrating energy compliance when you use the reference house modeling approach, because the reference house makes some assumptions that really mean that homes that have the right intent are sometimes challenged in their compliance just by the nature of the comparison, the nature of the calculation. And so this slide shows that there are some houses that this EUI metrics compliance pathway will favor. Dense houses, simple houses, small houses are going to have an easier time demonstrating compliance using this pathway, whereas more complex homes, larger homes, homes raised off the ground as shown in the right-hand slide, may still have an easier time demonstrating compliance with the reference house. And what's interesting here is that both pathways remain. The EUI metrics compliance pathway does not replace or displace something that's in the code. It adds another compliance option to it. And while there is something to be said about the complexity of compliance pathway options that we have in front of us, in many ways, I think that having an option that addresses these challenged housing forms directly is another good news story. It is a complex formula to understand out of the gates, and so you will need to ask your energy advisor to look at this, to understand it, and to help you apply it. But overall, I think that this is a positive story, and I'll give you guys the lightning round for comments on this one. Frank, go ahead.
Yeah, I totally agree with you. It's a great idea, and we don't have to dwell much on it. It's a great new um, method, predominantly fixing the issue with smaller, more compact geometries, which have been a problem in the reference and proposed approach. And we know that the smaller the units get, the more problematic it gets to model them in the performance path. So this is a really good approach. Even in 2010, when I was still at NRC and we started developing 936, there were some people saying, can we not just have something simpler? And so I'll put forward here my idea for the next code, which is actually a very, very old version of one of the first energy conservation codes in the world. But it is to decouple this method from the modeling data, because you still need, I guess, the input from a model, right, to use this. The version that I'm talking about is a 1995 German energy conservation law, and there was a formula for each climate zone based on the area of the home, the volume of the home, the number of stories, and the climate zone. And based on those, you create a budget for each location based on the heating degree dates were there, not the climate zone. And that is your budget. So in other words, you get a budget from that rather than having to run a model. And that would really then create a method that is truly between prescriptive, and you don't have to run a model. You just get a budget. It's linear. It's modeled on all the homes that NRCan knows how they perform, right? I mean, that would be my guess and my hope, that we eventually get to something that you can do on a single sheet with a single simple table like the points method, and then we would be really in good shape. Anyway, I'll leave it there.
Any thoughts on this path, Mike?
No, I'm not going to comment on good ideas because we have a lot more to cover that I do want to comment on.
Yeah, definitely some stuff to look into there, but another hopefully good news story. There's some really great work. I got to acknowledge Alex Ferguson and Sarah Gilani for their good work on that PCF. Okay, we're going to stretch. Well, I'm going to stretch myself as an energy advisor here a little bit. We're going to try and tackle the lateral loads introduction in PCF 1475, which addresses seismic and wind resistance in homes. I think that what we really need, and I think, Frank, you're going to speak to this a little bit, but this change is not so much introducing brand new topics as making them less exempted than they used to be. So there's more requirement to apply existing measures broadly than there used to be. And so this points to, this slide has a QR code to an illustrated guide produced by BC Housing, which you may find helpful. There's also a Canadian Wood Council tool to help you calculate lateral loads, and I believe CHBA has a tool as well, which Frank can speak to. But here, really, the primary takeaway is that lateral loads addresses the seismic and wind-resistant characteristics of a building, really with more emphasis on wind than we've had before, to resist not only the racking strength, but also uplift and overturning in homes. And it deals with this through two new terms to me: braced wall bands, which are imaginary zones within which we must place a certain number and type of braced wall panels by story and by length in order to resist those forces that are trying to take down our homes. And so in plan, you can see this shows the braced wall bands in blue. These are three-dimensional zones that carry up the full height of the building. And within those bands, with a certain amount of limited offset allowable, we have to place panels that are going to be shear panels effectively, resisting and tying our building down to the forces that are being applied to them. Now, what does a braced wall panel look like? Well, many of these wall types are going to be very familiar. They can be wood-sheathed products that have gypsum wallboard on the inside. They can have a number of different combinations of exterior finish. But what is more challenging for us to understand now is, as we move away from sheathing products, wood sheathing products, or perhaps as we have moved away from them over recent years and introduced exterior insulation applied directly to studs. Those assemblies now are very challenged in complying with this pathway, and you either need more wall area with the gypsum board serving that role, or to go back towards wood products as your exterior sheathing material. And so here's a sampling of wall types that can be treated as braced wall panels, but where you locate them and how you calculate them is really where the complexity of this change comes in. Now, there are three compliance pathways in the lateral load section of this that range from simplified but very conservative, meaning they're probably overreaching and asking you to potentially more than is necessary, but it's going to be very cut and dry as to this complies and this does not. Moving towards a table method and a calculation method that are more flexible but require more calculation, more inputs, and a deeper dive into the requirements of these new legislated things. So material cost and conservatism goes up as you go towards a simple compliance method. You can optimize and go towards precision, but you have complexity as you go towards the right hand side of this. Now, I'll give you the energy advisor perspective here before I hand it over to Frank, just to say that, this really appears at its surface to be a structural engineer's problem. Why are we talking about this as energy advisors? We know that every builder across Canada works very closely with their structural engineers to analyze every single design. Probably not the case. There's going to be some questions asked about that. But because we're talking about assemblies here, as energy advisors, this has direct impact. The advice that we are giving about what type of wall assemblies are going to help us comply with energy codes should at least be aware of or have in our minds that there are these other requirements for wind and seismic protection, which we have to consider as well. That might mean, more rigid materials, more wood materials, perhaps different framing schedules, and how that impacts our effective thermal resistance calculations will matter. And I think that's where the overlap lies. But certainly this is one that has a lot of anxiety around it and complexity from the builder's perspective. So Frank and Michael, I'll get your take on it.
Yeah, very quickly, in BC, they've already adopted this early, and the first, I'm starting with my bottoms bullet there, cost is more than what Codes Canada anticipated, and also the complexity of this method. It may be fine for engineers, but it's certainly not fine for builders. It's so complicated, and building officials, sorry, I also, that they just say, I'm going to hit the easy button, give me an engineering stamp. And now going to the first bullet saying, and you might mention that, it's not just in earthquake regions anymore. This applies anywhere where high wind and moderate wind loads apply. The wind load trigger for these requirements has been lowered. In other words, it will apply in some form in most areas in Canada. Even if you want to use a design method, so maybe I'll flip around. The simplified method is very, very, very limited. It has 10 limiting criteria. One of them, for example, is that you can only use it for homes that fit on a 10 by 10 meter floor plan, so 30 by 30, any shape in between, 30 by 30 feet. And as you said, Mark, no more insulating exterior sheathing by itself. You will have to have some wood-based or double gypsum board on both sides. So the wall types will have to be studied and how they fit. We have a backgrounder. We don't have a tool, but we have a backgrounder displayed there on the right that explains our three methods. And we are working right now with the CHBA BC and the BC government actually to expand the simplified method so we can apply to two-story, two-story and a wider footprint so that it applies to more houses.
Mike, any thoughts?
Yeah, you've covered most of it. The simplified method only works for a house that's 35 feet by 35 feet or smaller, which is none of our houses. So we're looking at one of the other two methods if this comes to Ontario. And so there's really two things for builders to prepare for if this ever sees the light of day in the Ontario code. Is one, in order to get your permit application in, you've got this much more complicated thing that you have to go through. I'm a civil engineer. I haven't spent hours on it, but I've spent many minutes, and it's just like I don't know if I, as an owner of a home building company, am going to want to invest the time to even figure this out. So, that's the builder's perspective of getting my permit application in, and then what's the plans reviewer going to do with this? So BC, luckily BC is going through it before us, and hopefully with their experience, if it ever makes it to Ontario, we'll know how we're going to manage our way through that. And then, the bigger thing though is what do my houses look like in this new world? If I'm going to be putting exterior insulation on my wall and I have to add structure to that, my wall thickness increases, my cost increases. Do I now pass the threshold where I have to go from an 8-inch foundation to a 9 or 10-inch foundation? And then the other thing that we may be faced with is some interior wall bracing. My open concept floor plans, do I find myself adding a wall somewhere in order to get the required bracing on the inside? And now, do all my floor plans still work or not? So there's quite a bit here. And I don't know if even builders in Ontario are going to want, I don't know if they're going to want to invest a lot of time to figure out how they'll deal with it when they don't even know if and when it's going to affect them. But this is a big one that if it does make its way to Ontario, will change how we build our houses.
Yeah,
Yeah.
I think if I may just add, you described it well. What's missing here, after those 60 pages of codes that you have to go through, the methods of what they want is very simple, right? Either sheathing, more fasteners, stronger fasteners, better bolts. But to arrive at which wall type and which spacing and which sheathing and how much is not it's not easily findable. There's nothing constructible there. It's all design, design, design. So for us, I think Part 9 is the wrong place for this. There needs to be more construction guidance. So, and you described that well. It's not even worth your time going through 60 pages to figure out factors and tables just to figure out, oh, we want, 2 meters of sheathing on that side and 1 meter of sheathing here. That's it. Or an internal wall. That's it.
And for what it's worth, we do have a comment in the chat that this is causing headaches in BC because of the complexity for designers as opposed to the execution. So yeah, we've got lots of takeaways, as you can tell from this webinar, lots of areas for us to spend more time. This last topic is certainly one of those spaces, and this is new, brand new in the 2025 building code. We're going to try and end on this in an unbelievably short amount of time to cover a very complex topic, unfortunately. But for the first time in our National Building Code, the 2025 code introduces operational greenhouse gas emissions levels. And there are a few compliance options in here. I'm going to jump ahead to a really quick introduction of what PCFs affect this. The two key PCFs to review, if you're interested in learning more about this, are 2004, which describes the performance pathway for complying with these new levels, and 2026, which describes the prescriptive pathways for complying with these levels. It's important to know that one of the big comments that was received in the public review, but that is still true, is that this compliance pathway, neither compliance pathway acknowledges the contribution of renewables on site. And so this is purely emissions from the home and from the electrical grids that the homes are connected to as well. Electrical grids across the country are trending to the good on average. Some provinces, like Ontario, in fact, are moving slightly in the other direction. But our sort of historical message of there are really bad emitting provinces is changing. And in order to address that, the emissions factors, this is a new term for many of you that you'll have to get familiar with. The emissions factor refers to the greenhouse gas emissions that are created in the generation and transport of electricity through grids to the homes that they are connected to. And in accounting for the impact on greenhouse gas emissions of a home, we have to take that electricity load and multiply it by the emissions factor for our location. The published table of emissions factors in the 2025 code uses forward-looking projections for electricity and takes the average of what those grids are projected to emit between 2031 and 2035 based on the best available literature at the time of publication. This is changing all the time in reality, but in order to put a mark in the sand, this table has been published in 2025 as one of the pathways for determining energy factors, and it is being reviewed and revised on a 5-year cycle with the current code's progression as it is going ahead right now. So I'll let you dive into that in more detail with the deck when you have it afterwards. But at a very, very high level, our compliance is going to target one of these levels that are notionally part of our collective climate targets as a country by 2030, a certain amount of reductions by 2050, getting to great or near zero levels of emissions from our homes. And the levels here, instead of being tiered 1, 2, 3, 4, 5, are levels like letter grades A, B, C, D, E, F. Again, as I mentioned, there are multiple compliance pathways for this. The prescriptive pathway gives you a table, a method where you identify the energy source and appliance types that you're using for space heating, the energy source and appliance types for hot water heating, and the emission factor bracket of your location to give you a guide to how many points of energy conservation you need to achieve to get to a performance level. This slide gives you level B performance with some examples of what that looks like. And the performance side gives you a calculation. Energy demand multiplied by X and hot water demand multiplied by Y, electricity demand, compared against the reference allowance, which uses a generic emissions factor for space heating and for hot water, and your location's emissions factor for electricity. Now, that's not enough information for you to go out and apply this methodology. For that, you'll have to watch this space for further webinars on how to do a deep dive into this. But suffice it to say that this is now available to the provinces and territories as they look at harmonization, and is potentially then available for them to require compliance with a level in the emissions code. I know that we're 1 minute over time, but if it's all right with our expert guests, I'm going to ask if you have 10 minutes to stay and comment on this and maybe answer a few questions. And for any attendees that do have to hop off the call, please look for the recording, as we'll capture this in the recording and it'll be available after the fact. So thank you for that. And Frank, I'll pass it over to you for some comment.
Yeah, happy to stay for a little bit. This is important, but it's a very short message. We think this should have never made it into the code at the stage that it is in. It is using emission factors for utilities over which builders have absolutely no control. And are just roughly like if you build a net zero home in Alberta with solar collectors on it, you're level D. And if you build a shed in Manitoba, you're automatically level A. It has no resemblance. Like there's so little that builders can do. That should have been thought out further. The benefits of this for society. I mean, this is greenhouse gas emissions. That's what we're all after, right? None of the benefits were stated. We don't know how much greenhouse gas we're saving by doing this. And my own back of the calc, never published before, but in this bullet, I'm saying 1.42% of savings in greenhouse gas emissions of the number that buildings consume. Anyone correct me if I'm wrong, but that there's so many reductions that I don't think this was worth it for the cost, for the additional cost, considering that we're moving to higher tiers, which also reduce our emissions, right? At zero cost, added, considering that we're already paying for the energy efficiency. So the biggest problem for us was the only thing that builders can actually control, and owners, is putting solar collectors on it, the only net zero emission or the only zero emission technology that we have a control over, putting solar collectors on the roof. Well, nowhere to be seen, not even mentioned in these code requirements. So shouldn't have made it. We think we should have waited until we have energy efficiency, operational, embodied greenhouse gas emission, and resilience all in one integrated package, and then put it in code, and only where it needs to be regulated. But this alone should have not made it, in our opinion. Thank you. Sorry.
Thanks, Frank. Oh, great comment. Mike, what do you think?
You know, from the builder's perspective, it's just confusing. Depending on how dirty the electricity is that's being generated in the province, I now have to build my house more energy efficient. So now I've got two scales I'm dealing with. If I understand this even correctly, I'm dealing with the tiers and which tier did my province choose to adopt, and I have to get those energy efficiency levels of the tier that was chosen. Plus, that's then being modified by how dirty the electricity is, adding other energy efficiency methods. And I just don't like builders in Ontario, you know, if they're like me, this is just, it doesn't make any sense. It's too confusing. We're dealing with moving targets. And, you know, I think this is just where they went off base. The way Frank said, this shouldn't be in here right now. And it's probably one of the main reasons why harmonization is going to be taking a step back across the country. They did it to themselves. It's unfortunate. I guess there's a final thing that I can say as a builder. If we had more site supers in the room during the code development process, we might actually be harmonizing, because we might have something that everybody could adopt and work with. This is just another challenge, and I hope with the Ontario line by line review of the code that isn't even up for consideration until they get it cleaned up and fixed up.
Well, thank you both. And I think it's important to point out just a couple of comments that came up in the chat. Well, first of all, the BC does have a zero energy carbon code, or a zero carbon code, excuse me, that has been enforced now for a few years. So again, we're looking at BC to see what happens. Is this causing confusion to have levels and steps both in place? And I just wanted to highlight one comment we got from Murray Frank in the chat, which points out that compliance with many of these changes that we've talked about today does not necessarily push us into engineers. And in fact, the work of energy advisors that are staying up on this topic, or non-engineers that are in this space, can support Part 9 builders in complying with these without pushing us into engineering fees just blindly. So I wanted to highlight that we are going to capture all of the chat comments afterwards. So thank you for everything you've put into there. And Mike, I think your last comment there is a great segue to our main call to action when it comes to codes, which is please do get involved. If you share the opinion of any of us on the call today, or if you have your own thoughts, then the public review process of the national codes is your opportunity to provide feedback. And even beyond that, there is the meetings are open to observers to come and participate and comment on. It takes time. It is volunteer effort, but it's important. And as Mike said, if we have more of the people that are implementing these things on the ground, giving feedback in real time, you saw in the first two slides that Frank presented that it's a challenging short window in many situations where that influence really does matter. So if you're not familiar with how to get involved with codes, reach out to myself, to Frank, to Mike, anybody who's been a part of that process in the past. We're happy to provide that guidance. And the takeaway at the end of the day is also, these changes are in the NBC 2025, but we don't have a crystal ball as to what that's going to look like in your location, in your harmonization situation. But I think we've heard everybody mention today at some point, it's worth being familiar with what they are so that if policy changes come quickly, you're prepared and you know where you stand already. So benchmarking and having a progression plan is something that we work with many of our builders to develop, and has been a success story for many people. With that, I want to say a really big thank you, both for the extra time, but especially for your expertise and commentary on the subject. Frank and Mike, it's been great to have you both on the webinar today. Thank you so much for participating. As always, it's great to have a conversation with you all about this. I'm going to leave off. Yeah, no problem. I'm going to leave off with just a few slides to wrap up. We do have more webinars in this Critical Canadian Building Science series coming this summer. Our dates are still being firmed up, but looking ahead to early summer, we're going to have a two-part webinar series on indoor environmental quality and the comfort lens on that with comfort expert Robert Beam. So please watch our website for that announcement. You can also, if you're not already on the list, join our Building Knowledge Builders Digest newsletter, which comes out quarterly, and we'll have announcements about our upcoming events there. You can sign up. We will post the link in the chat for you to sign up on that, as well as the link to, as was mentioned, the follow-up survey for today's webinar. We really do appreciate your feedback, both as Building Knowledge and for our presenters. So I encourage you to please take the time to fill that out and join us for the next in this series, where we'll have more experts, more expertise from inside Building Knowledge as well, presenting on topics that hopefully matter to you all. I'll leave it there for today, and it's been great to have such a great turnout for today's webinar. Mike and Frank, thanks again, and we'll see you all on the next one.
Bye.